When we think of secret weapons from World War II, we probably picture spies or code-breaking machines, maybe even super tanks. But what if I told you one of the most powerful weapons wasn't a weapon at all? It was a new way of thinking. A science, really, born right in the middle of a global conflict. This is the story of operations research. So let's start with a big question, one that the Allies were desperately trying to answer back then. How do you win a war when you're stretched thin, when resources are scarce, and when you're facing an enemy that seems to be everywhere? How do you win not just with bravery, but with science? Because you have to understand, the scale of the challenge they were up against it was immense. This wasn't just a war of battles, it was a war of numbers, of logistics, of supply chains. It was a war fought on spreadsheets as much as on the battlefield. Military commanders were literally drowning in problems that their training had never prepared them for. They had a limited number of planes, a limited number of ships, a limited number of people, and every single decision they made had life or death consequences. Making the wrong call wasn't just a mistake, it could cost thousands of lives. And we're not talking about abstract theoretical questions here. These were urgent, gut-wrenching problems. They had this brand new tech, radar, but no one really had a manual for how to use it most effectively. How do you decide where to send your planes for the biggest impact? And this is a huge one. How do you even begin to search the massive Atlantic Ocean for enemy U-boats? The team, for instance, crunched the data on attacks and found that the depth charges were set too deep. A simple change, setting them for a shallower explosion, dramatically increased the kill rate. That's the kind of stuff they were figuring out. So, when your top generals are stumped by problems of math and probability, who do you call? Well, the answer was totally out of left field. You don't call another general. You call a bunch of scientists. Yep, the British military turned to a physicist, Professor P.M.S. Blackett. His job was to build a team to conduct scientific research on military operations. And just like that, almost by accident, the field of operations research got its name. And you gotta love the team he put together. They nicknamed it Blackett's Circus for a reason. It was this motley crew of geniuses. Not just mathematicians, but physiologists, astrophysicists, even a surveyor. It was this incredible mix of minds, all looking at military problems in a way no one ever had before. Seeing them as complex systems that could be analyzed and, optimized. Their mission was laser-focused and crystal clear. Figure out how to get the absolute most bang for your buck from every plane, every ship, and every soldier. It was all about the most effective allocation of really, really limited resources. And this work was so revolutionary, it got its own formal definition. I love this phrasing from the UK's Operational Research Society. They called it the attack of modern science on complex problems. Attack. It's not passive observation, it's about actively taking on these massive puzzles and wrestling them into submission with data and logic. Okay, so how did they actually do it? What was this new method that gave the Allies such a critical edge? Let's get into it.
At its heart, what they were doing was taking the good old scientific method, observe, hypothesize, test, and applying it to something totally new. Instead of studying atoms or stars, they were studying systems of people and machines, like a bombing campaign or a naval convoy.
The whole thing boiled down to this really elegant four-step process. First, you have to define the problem with perfect clarity. No fuzzy goals. Then, and this is the really magical part, you build a mathematical model of the system. Think of it like a simulation on paper. Third, you use that model to test out different ideas and find the best possible solution, the optimal one. And finally, you take that math and turn it back into simple, clear instructions that a pilot or a captain can actually use. And that model, that was the real game changer. It was like having a crystal ball. For the first time, military leaders could see the probable outcomes of their decisions before committing troops and supplies. They could ask, what if? What if we fly this pattern? What if we schedule convoys this way? They could compare all the alternatives and pick the one the numbers proved was the most likely to succeed. So the war eventually came to an end. But this incredibly powerful new way of solving problems, it was just getting started. Its success was just too big to stay confined to the military. You had all these industrial managers in the UK and the US, and they looked over at what OR did for the war effort, and a light bulb went off. They were thinking, hey, wait a second, we have similar problems. We have limited resources, complex supply chains. We need to be more efficient. They wanted in on this new science. And from there, it just exploded. What started as a top-secret military tool in the 40s quickly spread to government and big industry. By the 1950s, universities started teaching it. And today, the principles of OR are quietly running in the background of just about everything we do. This is where it gets so cool. You can draw a straight line from then to now. The exact same mathematical logic that was used to hunt for U-boats is now being used by your GPS to find the fastest delivery route. The method for allocating fighter planes to missions, it's now used by airlines to create their flight schedules. It's the same fundamental science, just pointed at a different problem. Isn't that incredible? A science that was literally created to make war more effective has become one of the most powerful forces for efficiency and progress in the modern world. It's the invisible brain behind our global economy, and most of us don't even know its name. And really, its core purpose hasn't changed a bit since those frantic days of World War II. It's all about helping leaders make better decisions. It's about replacing gut feelings and guesswork with data and scientific proof. It's about taking action, scientifically. So that leaves us with one last big thought. This science was born to solve the single greatest challenge of its time. As we look ahead at the massive, complex problems facing us today, things like climate change, global pandemics, and tangled supply chains, you have to wonder, what's the next great challenge that can only be solved if we learn to think not just like politicians or activists, but like operations researchers?